Hello students, this video focuses on functions, what it means to be a function, and then how to tell whether or not an equation is a function. So, first of all, in a function, every component in the domain, which is the x values, goes to a different range y value. So every x in the domain has to go to a value in the range y. And as long as every x goes to a different y, it's fine. So this is a function, and it's fine that the 2 goes to the 4 and the 1 also goes to the 4. It's okay that the y's repeat. That's fine. However, if we had a function like this, let's say that the 2 goes to the 5 and the 2 also goes to the 6, then no, that would not be a function. Not a function because the 2 cannot go both to the 5 and to the 6. Alright, so function notation. Function notation uses f of x instead of having a y. So when you see this symbol here, this means f is a function of x. Okay, so f is like the name of the function, and then x is what the function is evaluated at. However, this does not mean f times x. People might think, oh, parentheses, that means times. This does not mean f times x. Let's look at an example. Here I have the function f of x equals this parabola. Let's see if we can evaluate f of 2. Well, to find f of 2, we simply plug in 2 for x. So now I have 2 squared plus 3 times 2 plus 5. And that gives me 4 plus 6 plus 5, which is 15. All right, we can do the same thing. We can also find f of x plus 3. So now I'm going to replace each of these x's with x plus 3. Okay, so here I have the same equation as the original. All right, here's the x, and instead of x, I have x plus 3 squared plus 3, and instead of x, I have again x plus 3, and then plus 5. Okay, so now I'm going to go ahead and solve this. X plus 3 squared is x plus 3 times x plus 3. Okay, and I'll just write in blue. Let's go ahead and distribute this out. Okay, we're going to do FOIL first, outer, inner, last. And we have to distribute the 3 as well here, which gives us 3x plus 9. Okay, so we combine like terms to get the answer. Okay. How can you tell if an equation is a function? Well, first thing you have to do is take that equation and solve for y. Now, when you are looking at the equation, there's a couple of different things you're going to look out for that are clues to tell you things that are not going to make functions. One, vertical lines. Anything that has a vertical line is not a function. What do vertical lines look like? That would be if you just have x equals a number. Okay? So if you go to solve for y and there is no y, then it's not a function. Another thing to look out for is y squared. And if it has a y squared in it, when you solve for y, you're going to end up taking the square root of both sides and getting plus or minus something. Okay? So when you have an x squared, that is not going to give you a function. It's not going to end up with being a function. So let's look at an example of that. What if I have y squared equals x? Is it a function? Well, the first thing we're going to do is to take that and we're going to solve for y. We're going to solve for y by taking the square root of both sides. The squared and the square root cancel to give me y equals plus or minus the square root of x. Now, I have a plus or minus in the solution. This is not a function. Let's examine why. The reason it's not a function is because there's a value of x. There are many values of x that you can plug in that would give you two different y values. What do you get when you plug in 4 into this function? Well, when I plug in 4, I have y equals plus or minus the square root of 4, which is plus or minus 2. So the problem is when I plug in 4, do I get positive 2 or negative 2 for y? Well, negative 2 squared is 4, and also positive 2 squared is also 4. Okay, so it's not a function because 4 gives two different answers. Okay, so let's look at this. Let's look at some examples. Okay, let's say I have square root of x plus 1 plus y equals 16. Is that a function? Well, I solve for y by just subtracting the square root part to the other side. And sure, that's a function. There's nothing wrong with that. I have a square root, but even so, it's still a function. When I look at this equation, though, I see that it has a y squared in it. So let's see what happens when I take this thing that has a y squared and I solve for y. First, I subtract the x squared to the other side, and then I take the square root of both sides. When I take the square root of both sides, the answer can be positive or negative square root. So that means I'm going to have two values here, a plus and a minus, which means that this is not a function.